Hello, Dr. Mark Harris, the next in our series of health lectures from beautiful Bozeman, Montana. Now today's topic, what we're talking about now is your hormones. And very often hormones are thought of as hormone replacement therapy or other things that are kind of specific. But really the hormones are far more than that. And they are important for our whole lives, and we're going to call this a symphony of optimal health. What we'll see, the hormones are a symphony in that they all work together, and it is necessary that they work together to optimize our health. Now, your hormones think of them as a informational pathway, as our nerves, as our other areas of the body. And if you talk to physicists, it's all about information. But we're going to talk about our hormones individually, and we're going to put them together and try and come up with a plan for everyone to have optimal health. Now, we'll first look at your adrenal glands. Your adrenal glands sit on top of your kidneys. And in your adrenal glands, you make DHEA, which is one of the things we talk about as the hormone of youth. We make cortisol. Very important cortisol, and changes with a lot of different factors. We make one called aldosterone. This is a little less known, but this is one that controls blood pressure. We make epinephrine and norepinephrine, which we used to call adrenaline and noradrenaline. This is the one that allows you to lift cars off your children. I think we've all heard that story, but I don't know if that really happens. Well, these are some of the hormones made in the adrenal glands, and as I talk about a lot of the hormones, we won't mention every hormone in the body as that would take 2 or 3 hours. Now, the ovaries and the testes, we make the estrogens, and we make that plural because there are 3 estrogens, estradiol, estriol, and estrone. We make progesterone, and we make testosterone. Now, we've just mentioned 8 hormones very quickly, and 2 different sets of them, but now we want to kind of look at how some of these work together. Now, a lot of the hormones that we've just mentioned, and all those 7 or 8 of them, are initially made from cholesterol. So cholesterol has become the big bad guy of heart health, but cholesterol is one of the most necessary and crucial chemicals in the body. Now, we make cholesterol in our liver, and dietary cholesterol is not really necessary because we are very capable of making this stuff. And cholesterol is useful in many things, especially now in the precursor to a lot of these hormones. And then we make one called pregnenolone. Now, it's unfortunate that pregnenolone sounds like progesterone, but it's not the same thing. And it's a precursor directly made from cholesterol to all the hormones we've talked about already: DHEA, cortisol, noradrenaline, adrenaline, estrogens, progesterone, testosterone, and not quite so much aldosterone. Now, we talked about this being a symphony, so we're going to start seeing how these all come together. From cholesterol, we make pregnenolone. This is primarily the first pathway. From pregnenolone, we can make aldosterone. From pregnenolone, we make progesterone. From pregnenolone, we make DHEA. Then, progesterone can be turned into cortisol, testosterone, the estrogens, inversely related, and DHEA can be made into estrogen, and DHEA can be made into testosterone, and DHEA can be made into progesterone. So now we see that this becomes a mess, but it also becomes a symphony, because in a symphony we have upwards of 30 to a couple hundred musicians, and individually they play beautifully, and if they're not coordinated, it is not a symphony of music. So we look at the first cascade. We're going to look a little more deeply at cortisol and DHEA. Now, these are inversely proportional. So as cortisol rises, DHEA goes down because the same precursor molecule is being used so we can really make one more than the other. Now we have a fella called Hans Selye, Austrian, and he termed something called general adaptation syndrome, or how the body responds to stress. And how the body responds at first is we increase our cortisol, and this releases blood sugar, and this is useful for running. Now, probably an adaptation to pre-agriculture when we got game, ate fruits and vegetables that grew wild, and ran away from things that were bigger than us. And if you're running from something bigger than you are, you have to run. You really don't have to think. But cortisol elevates at the expense of DHEA. And when stress first happens, cortisol goes up. And then under continued stress, cortisol starts to go down. And then under long-term stress, cortisol goes down and DHEA goes down. And the cortisol can be measured quite easily. And if you measure cortisol, and I've probably done this on thousands of people, and I've never seen one that is properly balanced yet. Because although we're no longer chased by tigers, we do have stresses in life. And now it's more or less like every hour or so we're chased by a tiger, or 10 times a day. Now, we also look at this cascade as estrogen and progesterone are balanced. Now, they are also inversely proportional, not so much that they're made from each other, although progesterone can be a precursor for estrogens, but really how they function together. And if one is elevated, the other will be lower, meaning it will overwhelm the function of the other one. And most often we see elevated levels of estrogen in the premenopausal years, and this will cause various symptoms of premenstrual syndromes or premenstrual dysphoric disorder, what they call PMDD, endometriosis, emotional changes, even cancer, because estrogen and cancer are related in many ways, but when estrogen is not properly regulated, that's when we get more cancers. So now we look at these hormones. We can call these steroid hormones, and not all hormones are steroids, but many of them are, the ones we've been talking about so far. And what are they responsible for? Well, how much energy we have, how much energy we have for the whole day, feeling energetic, how strongly our emotions are controlled, and emotional well-being, our blood sugar, any pretty much any pre or postmenopausal symptom, how clear our thinking is, if we gain weight or burn fat, and our digestive health, which shortly we'll see another cascade of things. So really, we can talk about these hormones, and we haven't even talked about all of them yet, that can impact virtually every health issue that is possible. Now, we're going to look at a scenario, and we talked about that DHEA and cortisol are affected by stress, and we talked about tiger stress. Well, we don't get chased by tigers too much anymore, but we have family stress, we have coworker stress, we have time stress, we have health stress, we have financial stress, we watch the news, we have stress. And this, to the body, is the same as being chased by a tiger. So what happens under that stress is DHEA goes down and cortisol goes up. Now, proper levels of cortisol manage your blood sugar, your immune system, your emotional well-being. But improper levels will destroy your gut bacteria. Now, your gut is made up of a lot of different kinds of things living there. You have a lot of different kinds of bacteria. You have some very good bacteria. You have a little bit of bad bacteria. You have yeast that grows in your gut. You have low levels of small parasites. And it's all kept in balance by the numbers that are usually there, meaning by the gut bacteria. So if that is destroyed, then the other things that are usually in a very low level can grow. So this can be yeast or candidiasis. This can be parasitic growth. This can be bad bacteria, or what we end up with what's called a leaky gut or intestinal malabsorption. So our absorption does get impaired. If we don't absorb things, our energy goes down. And among the things that can happen then, our memory gets worse, our estrogen progesterone balance will go off, our blood sugar will go off, our immune system will go off. So now you see that emotional stress has impaired every aspect of your health via DHEA and cortisol, which are made in your adrenal glands. So if you are under stress, it's important that your adrenal glands don't have that huge response, and adrenal balance becomes the key here. Now, we talked about emotional stress, and we're all underneath it all the time. And then we have perhaps my favorite photo being presented today. We get low energy. I just love that one. Okay, now we talked about estrogen being off in relationship to progesterone. So there are many things that can change estrogen metabolism, and I'm not going to read you the entire list, but what I am going to do is summarize this list. But what is important to realize first, if we have commercially raised beef, chicken, and pork, because they are fed hormones, and the hormones that are in the flesh that we eat change our hormones, and this would be in other dairy products as well. City water that's not filtered can alter our hormones, also dryer sheets, fabric softeners, various drugs, coffee, and a lot of the containers that are made of plastics, most notably styrofoam, which are often used for disposable hot beverages, those kind of white foam cups that we drink out of. There are a couple of herbs that will do this depending on how they are prepared or if they're not used properly. There are various insecticides that are used, some of which have been outlawed, some of which are used on our own lawns, some of which are used in other countries, and some of which are used in the foods that are imported from those countries. Various detergents, various electrical insulations, and various plasticizers. So if we use plastics, if we use insecticides, if we use various drugs, if we eat, if we use shampoos, soaps that contain what we call certain kinds of waxes. So what these are either estrogen mimics or they inhibit estrogen. And this is things we're talking about for estrogen, but other hormones can be impacted as well. But pretty much these are what affect estrogen, can either increase it or decrease it, but either way, you're going to have hormone irregularities. Now we're going to talk about thyroid hormone now, and we're going to have our first exposure to biochemical diagrams. Now if you look on the very left, we have one called tyrosine. This is a breakdown product of protein. You break down protein, you make this chemical, or it's one of the chemicals that makes up protein. That's called tyrosine. And then you hook up 4 iodines on the very next picture, which we call T4. So 4 iodines in the positions you see, and T4 is not a highly active hormone. You make it in your thyroid gland, but it's not terribly active. Then you also make T3, and now you see the same backbone chemical with 3 iodines instead of 4 iodines, and that is an active hormone. That lasts for about 3 hours in the body, up to 7 hours. And then you have to convert T4 into T3, and there's various things you need to convert it. And if you don't convert it well, you'll get mid-afternoon fatigue. Now we also make something called reverse T3. And you can see the only difference is an iodine is displaced on the left side of this molecule from a lower position to an upper position, but reverse T3 is not active. And why we make this stuff is so we can sleep at night. If we have active thyroid hormone, we wouldn't be able to sleep. So as lights are turned off and melatonin levels rise, which is another hormone we'll be speaking about shortly, then we make reverse T3, we're able to sleep, and then after we eat breakfast, it's reconverted into T3, and we have energy throughout the day. Now, we're going to have a collective groan for what I'm about to show you. And I'm terribly sorry. Now, this is something we've all seen before and have promptly forgotten, the periodic table of the elements. But there's one area I want to call your attention to, and we won't spend an inordinate amount of time. Now, if you look along the bottom, there's a group in yellow called halogens, and this is also along the right side of this chart with an F, a Cl, a Br, an I, and an At, and then in white a UUS, but that's a man-made element. It doesn't really occur in nature. Now, the F is fluoride, and the little number to the left of it is 9. The Cl is chlorine or chloride. The Br is bromine or bromide, and the I is iodine. And the At is astatine. Now, we looked a couple slides ago, we saw that iodine is used to make thyroid hormone. Now, if we look higher up this chart at bromine, chlorine, and fluorine, the lower the number, meaning bromine has 35, chlorine 17, fluoride or fluorine 9, the lower the number, the more strongly these chemicals can bind to other chemicals. So, this becomes important to thyroid health. And this is as much time as we're going to spend now on the periodic table. Well, we'll spend one little bit more time. Chlorine can be in tap water. Chlorine can, salt, sodium chloride. Bromine is used to whiten bread. And also it's used in some people's swimming pools, thinking that it's a lot healthier than chlorine. Well, it's perhaps a bit healthier, but not that much healthier. And fluoride is widely used throughout industry, and our biggest exposures would be through our toothpaste and our water. Now, another look at how thyroid hormone is made. We showed the tyrosine molecule a moment ago, and then iodine is attached to it. But if one of the other halogens comes in, it displaces iodine, and then the other chemical can take its place. And the one that will do this most strongly is fluoride. Fluoride attached to tyrosine is a non-active thyroid hormone. Now, this on a lab test will show perfectly normal, but in the body will have no function at all. So this is why you can have a normal thyroid lab but still just feel terrible. Now, if we look at some of these chemicals below, what we are showing here in glass tubes are chlorine, bromine, and iodine. Now, if you look at what was written here when I got this photograph, the last line says fluoride could not be included in the image due to its high reactivity. So, they wouldn't even touch the stuff or bring it into the lab to stick it in a sealed glass tube. And this is the stuff we're putting in our toothpaste and putting into our mouths and our systems. All right, now, we talked about T4 to T3. And to convert this, you need a couple of things. It takes place in the liver, the kidneys, and muscle tissue. And this can be affected by stress, poor nutrition, if you're ill, if you have selenium deficiency. Selenium is found in Brazil nuts and a couple other things, but a lot of people don't get enough selenium. Some prescription drugs can do this, interfere with conversion, as can heavy metals and free radicals. Now, free radicals are what we have a lot of terms for free radicals, reactive oxygen species, free radicals, but what we call oxidative stress. And oxidative stress is the process that causes iron to turn to rust, and it also causes us to turn to rust and can interfere with turning inactive thyroid hormone to active thyroid hormone. And then reverse T3, if we're low on vitamin B12, if we have low iron, if we have stress in our life. So now we've seen stress affecting our adrenal glands, affecting our weight, our metabolism, our estrogen progesterone balance. And now we also see it affecting T3. So we have the cortisol changes. We have the adrenal, the gut, and the thyroid all being affected via cortisol, via stress. And then also T3 will not be converted with low iron or low vitamin B12. And vitamin B12, with each passing decade of life, gets more difficult to absorb through our digestive system. And if we have stress and we have gut problems, because our gut bacteria were killed off, we have even more trouble absorbing vitamin B12. So now we see the symphony of hormones is really stretching beyond hormones. It's affecting absorption and nutrition. Now, what does your thyroid do? It gives you energy all day long. If you're converting T4 to T3 and not being stuck in reverse T3, thyroid controls estrogen. If thyroid is low, estrogen will be high. And now we've seen about a lot of different factors that can impair our thyroid. So yet another thing that will raise estrogen levels. Thyroid controls our cholesterol production. If you have high cholesterol, that's a thyroid problem until proven otherwise. It controls your metabolism. Now, what do we mean by metabolism? Well, that's if you can burn fat or not. And when people have low weight and low memory, they first think thyroid. But it might be nothing to do with thyroid, but it might be everything to do with how thyroid is manufactured or how it metabolizes. Thyroid is important to your memory. It takes about 21 years for us to fully develop our brains. So young children who don't get enough thyroid hormone get impaired brain development. And they are diagnosed with this thing called cretinism, which really means idiot. So it's really not a kind diagnosis, but that's how important thyroid is to our brains. Now, adults have fully formed brains, but thyroid is important to the function of our brain in addition to the formation of our brain. This will affect our memory and our concentration. Thyroid is important to heart function. Thyroid is important to oxygen levels. And oxygen ultimately determines how well every single cell in your body works. And thyroid works at the level to let oxygen into your energy producing cells. Now, how do you find out how your thyroid's working? The typical test for thyroid is one called TSH, or highly sensitive TSH. It's been termed highly sensitive because the older test was so notoriously inaccurate that they had to come up with a better test, but the better test not terribly accurate either. Now, one of the things we like to look at is T4 and T3 and reverse T3. And this perhaps is the most important measure of how well your thyroid is actively working in your body. If you have a greater than 20-to-1 ratio of T3 to reverse T3, you're probably feeling pretty good, and your metabolism is working well, and everything else is feeling quite good. And this is a blood test measure, fairly easy to measure and not terribly expensive. Now, testosterone, we haven't given too much attention to yet, but we're going to give a little attention. Now, testosterone is typically first thought of to be abused. And what happens if you abuse testosterone? Well, you look like this guy. Now, testosterone is an important hormone and it can be abused, and you can end up looking like this fellow. I'm not sure why he's holding a picture of a bicycle, but he is. But anyway, no one gets like this without some kind of hormone abuse. So what does testosterone do at a proper level? Our muscle tone, our muscle building, not like the guy before, but maintaining our muscle, our libido, and these are things that typically decrease with age. And both men and women will have lower testosterone production by about mid-40s. And this can also be affected by your DHEA and cortisol levels. So again, can be affected by stress. Testosterone is a big regulator of the menstrual cycle. So testosterone is not just about men's health. It's important to women also. Now, testosterone is also thought to be a big factor in prostate cancer, but this is not borne up in the literature. So really, testosterone has virtually nothing to do with cancer. Now, men with prostate cancer are usually given estrogen to drive down their PSA levels, which it does do. Then also gives men breast tissue and increased risk of breast cancer in a male. Now, what seems to be happening in testosterone, the data shows that if testosterone is low, we have increased incidence of prostate cancer. So there seems to be an optimal level. If testosterone is very low and you have prostate cancer or benign prostatic growth, when you first start to increase testosterone, you will increase PSA levels. But then you get to a saturation point or a physiologic saturation point, meaning the amount you're supposed to have, and then PSA and prostate cancer are unaffected and or reversed. Now, testosterone is also beneficial to blood sugar. And if you see a man mid-40s to mid-50s who starts getting blood sugar irregularities, you really should know what testosterone levels are and correct them if they're off. Testosterone is highly preventative of Alzheimer's disease. And we're going to diverge a little bit to talk about Alzheimer's as it relates to testosterone and another couple of nutrients. And then testosterone is important to the balance of other hormones, what we've been terming the hormone symphony. Now we're going to talk about Alzheimer's for just a minute. And this is not exhaustive talk about Alzheimer's, but as it relates to estrogen and one other nutrient, and testosterone. Now the estrogen and testosterone levels are a contributing factor to the development or non-development of Alzheimer's disease, as is copper. Now in copper, what that has to do with it, there's this chemical that takes toxins out of the brain called LRP, which stands for low density lipoprotein receptor related protein. Don't know who thought that was a good idea, giving it that name, and how LRP stands for that is a bit of a mystery to me. Now, first off, we're going to talk about two different proteins in the brain, alpha amyloid protein and beta amyloid protein. Now, we're going to call alpha amyloid protein, this one is the happy, good amyloid protein. This one does not contribute to Alzheimer's disease and is perhaps most likely protective of Alzheimer's disease. Beta amyloid protein is the one we don't wish to have. This is a byproduct in the brain that can build up, and if it builds up, it takes the lining off of the nerves and they tangle up, otherwise known as Alzheimer's disease. And both these will be shunted toward alpha amyloid protein with proper estrogen and testosterone levels, and will be shunted to beta amyloid protein, the bad one, with lack of estrogen or testosterone or improper levels. Now copper, this thing we called LRP, low density lipo, etc., we have a waste product in the brain, and that was what we called the beta amyloid protein. And we have and that LRP helps us remove that beta amyloid protein, that bad protein, from our brain. And if copper is elevated, then it interferes with LRP and we're unable to remove beta amyloid protein. So what becomes very important is your copper level. Now, copper is not just a bad guy. Copper is used for your bones. Copper is used for some hormone balances. Copper is important. But like most things, we need the proper level, and this can become elevated in people. So if you measure in your blood your zinc to copper ratio and ceruloplasmin, which tells about how bound copper is in your body, this can give you a big indication to two big things in your health: your propensity for getting Alzheimer's disease and your propensity for getting cancer. If copper's higher than zinc, you're more likely going to get cancer than if zinc is higher than copper. Now, human growth hormone. Until about age 17, we use this to grow, and this is how we reach our height. After age 17, this really should be called human repair hormone, because it helps us repair a lot of the things that wear down during aging. We make this very well until about age 55, and then we make it less so as time progresses after age 55. And then this one can also be affected by trauma, a whack on the head, even riding on a Ferris wheel, or wearing braces when you're a teenager. So various things impact our ability to make human growth hormone, as does when we eat our meals. We make more human growth hormone in a fasting state. So if you eat anything after dinner and before breakfast, it impairs your growth hormone production. And impaired growth hormone production is going to negatively impact your health. And we want to make human growth hormone as long as possible, because taking growth hormone becomes, for most people, cost prohibitive. To take it properly, it can cost between $300 and $800 a month, and the only way that's useful to do it now is injections under the skin. And unfortunately, for women seem to need about twice the amount that men need to get any effective dosage. So it becomes more expensive for women to take than men. Now, there are changes happening in our ability to take human growth hormone, because probably for most people, it would be a beneficial thing by mid-50s to 60 years old. So there is a new thing in chemistry where it's going to seem to be effective, that the hormone within perhaps 5 or 10 years can be used only once a week. And at that point, the cost should become affordable to most everybody, but it's not available yet. Now, it's made in our pituitary gland, and if you see on this diagram, the pituitary gland is a very small structure at the base of the brain, near the brainstem. And there's a tiny little area between it called the stalk. That's how the pituitary is connected to the hypothalamus gland, the two what we should call master glands. And that stalk is fairly fragile, and this is why trauma can affect the functioning of this gland. And then the pituitary gland itself is going to give control to our thyroid gland, our adrenal glands, our ovaries, testes. So they call this the master gland, even though it gets its signals from the hypothalamus. So then the adrenals affect the thyroid affects the adrenals, the thyroid affects the ovaries, the adrenals affect the testes, and the adrenals affect the ovaries. So as you can see, we have the master control from the pituitary gland, but then everything else controls everything else. So then the symphony takes place. So what's the message here? Everything needs to be balanced. We're going to talk now about neuropeptides. While these technically are not hormones, we can think of those as brain hormones. Now, how they differ from hormones is they tend to act on a more local area, and these are not made from cholesterol. And there's probably a dozen different neuropeptides or brain hormones, but we're going to talk about 4 major ones. Serotonin is the one that makes us happy, our happy hormone. And then later in the night, converts to melatonin, which we'll talk about separately. Melatonin then gives us good sleep. GABA, or gamma-aminobutyric acid, this is our calming hormone. And it also helps us get restorative sleep. We make one called acetylcholine. This is our decision-making hormone. This is our memory hormone. So you see, this person has to decide on have a nice day or screw you t-shirt. And then we have dopamine. Dopamine is important to our learning, our ability to retain information. And dopamine seems to be controlling of every other neurochemical. So once again here, we are seeing a symphony. Now, dopamine is made from the same precursor as thyroid gland. So now if we have way back, we remember the periodic table of the elements? Well, if we got those in our system, fluorine, chlorine, bromine, these are going to adversely affect dopamine, just as they adversely affected the thyroid gland, production of thyroid hormones. And now, since dopamine is affecting all these hormones, we have basically a strike of our symphony musicians. Nothing's going to work that well. Now, the pineal gland, the pituitary gland is called the master gland. The pineal gland is often called the seat of your soul. And perhaps this is why. We have a small molecule called DMT, or dimethyltryptamine. Tryptamine or tryptophan is another breakdown product of protein, from which we end up making serotonin also, or happy hormone, but from it we make DMT. And this has been called the spirit molecule. Well, why is it called that? Well, when we have dreams at night, often we dream about things that we do not or cannot do during the daytime. Often we fly, or things happen, we don't get hurt. DMT seems to be a molecule that inhibits other senses. Why is that important? Well, if you're going about your physical day-to-day activities, what is most important at that point is your physical senses. Sight, touch, smell, you need to drive a car, you need to have all those senses. When you're dreaming at night, those don't become necessary. And then also, as we get to various states, sometimes in meditation, we experience spirituality, or various herbal concoctions can help us do this. And what these seem to do is increase the levels of DMT, or dimethyltryptamine, and then this removes the filter from the other things that we might experience. So some interesting things about that. Now, also in our pineal gland, we make melatonin. People know melatonin. You can buy melatonin over the counter. And melatonin helps you sleep, but it does other things as well. Melatonin is preventative of cancer. And melatonin, like other hormones we make less of as we go through each decade of life, melatonin also is healthy aging. Melatonin helps the other places where our body has receptors for hormones, makes them more receptive to the other hormones. So once again, we see the hormone symphony. Now, how do you measure your hormones? You can do it in blood, urine, or saliva. And all of these have their strengths and weaknesses. So we'll talk about those in a little detail a few more slides up. Now, how do you balance your hormones? You can do it with your diet. You can use herbal medicines. You can use homeopathy. You can use bioidentical hormones. And what's a bioidentical hormone? We'll be showing you the difference between a bioidentical and a non-bioidentical in the near future. Okay, so what do you do dietarily? Well, you don't want to look like this guy or girl. When we have what we call morbid obesity, or we have a lot of weight built up, the fatty tissue will alter our estrogen production and what our estrogen turns into. And we have breakdown products of estrogen, and fat tissue will make us break it down to undesirable forms. Now, the undesirable forms and the desirable forms of the breakdown of progesterone. 2-hydroxyestrogen, we'll call that the good one. 4-hydroxy and 16-alpha hydroxy, we'll call those the bad estrogens. And we want a ratio of the 2-hydroxyestrone to the 16-alpha hydroxyestrone to be greater than 0.4 to 1. And this can be measured and should be measured, especially if you have family history of breast cancer, uterine cancer, or prostate cancer. Now, how do you do it herbally? There are various herbs for this: black cohosh, blue cohosh, angelica. There are various herbs for your adrenal glands: ashwagandha, Siberian ginseng, and licorice. But you have to be careful with licorice. If you have just the straight form of licorice, it can be adversely affecting blood pressure. Thyroid herbs, bladderwrack, and you can see this is, well, it looks like seaweed, yes, because it is a seaweed, and it contains iodine. That's why it's important for your thyroid. Coleus friscoli, usually used for thyroid balance over or under function, and Coleus friscoli, unfortunately, is the common name for that herb. And now, the next one is not technically an herb, it's an amino acid, it's a protein. But tyrosine, as we saw how important that was for your thyroid, and tyrosine is available as a nutritional supplement. Now, we'll talk a wee bit now about bioidentical hormones. If we just look at estradiol, that is the most active of the estrogens, we have this molecule. And we're just going to show now testosterone. You see the very same backbone, and you see there are about 7 or 8 differences in this molecule. They look fairly minor, but it's enough difference to make a man versus a woman. Now, if we look at synthetic estradiol, we see this molecule. Now you see the backbone, we start to see differences, and the backbone looks a bit more like testosterone than it does estradiol. But then off on the left corner you see something that looks like it doesn't belong there. An S sulfur with 4 oxygens with various different bindings all around it. Now this looks like a very different molecule, and this is more different than estradiol than testosterone is. So why does it look like that? Well, this is one of the synthetic hormones that we would get in a prescription drug. And in order to make this drug patentable, you have to add something to it that is not human. So there were a couple of studies on the synthetic hormones. First off, there was one in homeopathy. Hormones were measured. This was in postmenopausal women, so women, they weren't expected to have good hormones. They were given the homeopathic doses of the hormones, and technically there was no hormone there at all. There was the energetic signature of the hormone. The hormones were remeasured, and all of them came back normal. Now, we had hormones that cause problems. But do the bioidentical hormones, the hormones that are the same as people, do they cause the same problems as the synthetic hormones, which we'll talk about next? But the bioidenticals seem to reduce osteoporosis, restore bone health, reduce premenopausal and postmenopausal symptoms, improve cholesterol, emotional well-being, sleep. We talked about Alzheimer's, cancer, heart attack, energy, and memory. That's what the bioidenticals do for you. But do the synthetics do the same thing? Well, there were 2 big studies that were done, the HERS-1 and the HERS-2 study. These appeared in the Journal of the American Medical Association and in the Journal of the American Medical Association. They both were in there. And the HERS study was in 1990 or the year 2009. But anyway, what it showed was they used progesterone and progestin. These are 2 synthetics of both estrogen and progesterone, synthetic hormones. And they found it increased the risk of blood clots, increased the risk of heart attack, increased the risk of Alzheimer's disease. And they actually ended the study early because of the effects it was having on the women in the test study. Then HERS-2 came out. They were just wanted to look really at this time did it prevent heart disease? And it showed it did not. So, you've got bioidentical hormones that are crucial to your health and some byproducts that are detrimental to your health. So how do you measure these? Well, we have to look at if they're free versus bound. And free hormones are better measured in saliva. Free hormones have a smaller size than bound hormones. So free hormones pass into your saliva, whereas bound hormones do not. And this is very effective for a certain class of hormones, and it's a pretty easy test to do. And this becomes especially important for cortisol. Now, cortisol we talked about as being a stress hormone. Well, if you stick a needle in your veins, this is kind of like being chased by a tiger. It's stressful, and your body will dump out higher levels of cortisol as soon as that needle is stuck in there. So they will rise immediately in the blood, and you'll have, in a blood test, it will show an inaccurate level of elevated cortisol. So what is best effective to measure in your saliva are all the estrogens, progesterone, testosterone, DHEA, cortisol, melatonin, all good for measuring in the saliva. Now, blood measures are very good for insulin, IGF-1, and thyroid hormones. Now, IGF-1 is used to measure how much growth hormone you are making. There's not a good test to measure growth hormone directly. There is a test, but it's quite expensive. So IGF-1 can be measured. Insulin can be measured very nicely in the blood, as can, of course, blood glucose, but glucose is not a hormone where insulin is. And if all your blood glucoses show very good, that doesn't necessarily mean you are headed for a diabetes-free life. Measuring insulin is perhaps the best measure for your blood sugar regulation, insulin both at a fasting level and insulin after a sugar type meal. Now, what's best to use for urine? If you're interested in the breakdown products of urine, which we earlier termed 2-hydroxyestrone, 4-hydroxyestrone, and 16-alpha-hydroxyestrone, these show up in urine. They don't show up in blood or saliva. So if you have family history of cancer, prostate cancer, breast cancer, uterine cancer, it's best to measure these in urine. And the only way to do this is a 24-hour urine collection. So you walk around with a jug. Now, what do your hormones do? Your metabolism, your ability to burn fat and make energy. Your libido, how interested you are in the things we were once very interested in, and perhaps the only thing we were interested in as teenagers. We prevent Alzheimer's disease. Remember the good and bad protein in the brain? And don't forget, copper was important there also, so measuring copper, zinc, and ceruloplasmin. We prevent heart disease with bioidentical hormones, but not with synthetic hormones. Our memory gets better. Our muscles are preserved. And muscles ultimately will determine our blood sugar regulation. We have better elasticity in our skin, so meaning the skin doesn't sag with each passing decade of life. Our blood sugars are balanced, so again, important for blood sugar regulation and the prevention and treatment of diabetes. We decrease our risk of getting cancer via hormones and copper and zinc, and our aging process slows physical aging. So, hormones are much more than hot flashes. Hormones are part of every single health condition. So your hormones can and should be measured, and measured where they are most effective for giving us the information we want. So take-home message here, get your hormones measured. They should be balanced. The hormone symphony. And they are part of a bigger symphony. What you eat and how you absorb it. We talked about your hormones tonight. Your muscles and your bones. If they're off, you have pain. Your emotional well-being. Your exercise levels. Your energy balance. Total body burden. What is in you that should not be in you. Heavy metals, chemicals, infectious agents, and oxidative stress, or what we call rusting, and the electromagnetic stress of modern life through cell phones, computers, and power lines. So this is a bigger symphony, and we'll talk about all those with future lectures, as we've already talked about some of the others. Again, my name is Mark Harris, and I'm in Bozeman, Montana, right here, lovely Bozeman. If you have questions or wish to contact me, contact information is available to you right there. And if you have questions, there is contact through my website. You can ask questions or perhaps call. I hope you found this very informative, and there will be more in this series as we continue. Thanks for listening.